Okay, let's do this. All about triangles. Triangles are awesome. There are three types of triangles that you need to know and learn and love. First, the right triangle. This is an awesome triangle. This is a right angle, which means it is a 90-degree angle. Why right triangles are awesome is because of a thing called the Pythagorean theorem. If you want to Google it, you can Google it. It's called the Pythagorean theorem, which states that A, B, C are the lengths of your triangles, and you see I almost wrote squared because I wanted to say A squared plus B squared equals C squared. So for example, and I'm going to use a very famous right triangle now, if you have 3 here and 4 here, you will know that A squared, so 3 squared plus B squared, which would be 4 squared, will equal C squared. So that's 9 plus 16 equals C squared, or 25 equals C squared, and then we take the square root of both sides, and we get 5 equals C. So the famous triangle is the 3, 4, 5 right triangle. That's a right triangle. Okay, next famous triangle that you need to know is the equilateral triangle. The equilateral triangle is like the perfect friend who's super boring because they're like, oh, I'm perfect, but they're really just super boring. Each angle is the same, and each side length is the same. Because each angle is the same, and you know the angles have to add up to 180, each angle is going to be 60 degrees. And each side length can be whatever you want that side length to be, but the side lengths all have to be the same. So if you know all the side lengths are the same, you know it has to be an equilateral triangle, and you know the angles have to be 60. So for example, if you're told that you have a triangle and each side length is 2, 2, 2, you know that that angle has to be 60 degrees. Which leaves us isosceles triangles, which are the coolest triangles. Just bear with me here. Okay, if you have an isosceles triangle, which means you have a triangle where 2 lengths are the same. So if you have 3 sticks and 2 sticks are the same length, that means you have to make an isosceles triangle. But importantly, that also means that 2 angles, these 2 angles, have to be the same as well. Think about it. If you have a stick that's that long and a stick that's the same length, where else are you going to put the third stick to form a triangle that does not leave you with the same angles here, the same angle measurements here? Answer, you can't do it. Why? Because isosceles triangles are awesome. So, if you just know one angle in isosceles triangle, you can figure out all the other angles. For example, if this guy is 30, well then what are those 2 guys? Well, you know they all have to add up to 180, right? So these 2 have to be the same. That guy is 30. That means these guys have to add up to 150, and they have to be the same, or 2x equals 150, or they both have to be 75. Get it? That's why isosceles triangles are awesome. Question 1, which best represents the value of y in the figure below? And remember, it's a right triangle because you have that little rectangle there, so you're excited about that because you know that means that you have a, b, and c, and a squared plus b squared is going to equal c squared. Why? Because it's the Pythagorean theorem, and it's amazing. So a is 2, so 2 squared plus 6 squared will equal c squared. That's 4 plus 36 equals 40 equals c squared. Get the square root of each side. The square root of c squared is obviously just c. What's the square root of 40? Well, the square root of 40 is like the square root of 4 times the square root of 10, right? Square root of 4 is 2. Square root of 10 is the square root of 10. So there we go. Your answer is c. And we're good to go. Question 2, which best represents the area of the figure below? Oh my gosh, it's not looking for the side length, it's looking for the area. So don't think it's looking for the side length because you read the question and it's looking for the area. But because it is a triangle, you know, base times height divided by 2 will give you the area, right? The area of a triangle equals base times height divided by 2. 6th grade was so much fun. So we need to find the height, so we need to find this side, but then we're just going to plug it into our area formula. So what are we going to do? Well, we know it's a right triangle, and we know a, b, c, and a squared plus b squared is going to give us c squared. And we have c this time. We don't have a. So what do? Well, it's our variable. A squared plus b squared, that's 8 squared, equals c squared, that's 10 squared. So we have a squared plus 64 equals 100. So it's minus 64 from both sides. And we have a squared equals 36. Square root both sides, that's fun. A squared, square root of that, a. 36, square root of that is 6. You might be like, well, it could be negative 6 too, because negative 6 times negative 6 is 36, but you can't go to negative space in a triangle. It just doesn't make any sense. You know, it's like, we're not doing science fiction here, we're just trying to deal with a triangle. So don't think it can be negative 6, it's just going to be 6. Oh, well, there we go, 6, 8, 10, that should be kind of familiar because there is a famous triangle that we talked about before, that's the 3, 4, 5 triangle. Multiply 3 by 2, 5 by 2, and 4 by 2, you get this other famous triangle. So they are, wait for it, similar figures. That's fun. Okay, so we have 8 and 4. And we plug that into base times height. Area equals 6, I'm sorry, did I say 8 times 4? 8 times 6. All base times height, excuse me. 8 times 6 divided by 2 equals 48 divided by 2 equals 24. So the area is going to be 24. Boom, we're good. Question 3. Which of the statements below is correct about this triangle? Okay. We have 5, 13, 12. That's kind of weird. Okay. It may be a right triangle because of that. It must be a right triangle because of that. It may be a right triangle because of this. And it must be a right triangle because of that. Eesh, that's kind of miserable. All right, well, we know if it is a right triangle, then a squared plus b squared is gonna give us c squared. That's kind of boring by now, right? So 5 squared plus 12 squared is gonna equal 13 squared. Let's see if it works. 5 squared is 25. 12 squared is 144. And 13 squared is 169. Oh, look at that. 169 does indeed equal 169. And the point here is if it works, if a squared plus b squared equals c squared, it has to be a right triangle. Think about it. If you have sticks that are this length and you were trying to decide what triangle to make, you could only make a right triangle. It is like so important that you could only make a right triangle, and you can see why that is so. Where else are you going to put this little, stick that's 5? If you lay down a 12 and then you have a 5 and a 13, there's no way you could lay them down that could make a triangle, because it would, if you try to go less than 90 degrees, it would look like that. If you try to go more than 90 degrees, it would look like that. You can't form a triangle that's not a right triangle if you have sticks of these lengths. So think about it. Don't fight it. Just let it absorb into you. You know this May business has got to be wrong. Okay, so let's just do the math. This is 144 plus 25, it's 169. Square root of 169 is 13, but that's 13 squared. That isn't 13, that's 13 squared. Oh, that little guy there, little exponent, oh, that messes that guy up. Sorry, B, you're not the right answer. It's got to be that one. We're good to go. Okay, question 4. AB is the same length as BC. Pew, pew. That's awesome. It's an isosceles triangle. Angle BCA, angle BCA is 30 degrees. That guy there is 30 degrees. What is the measure of ABC? Well, if that guy's 30 degrees and you have an isosceles triangle, which you do, which is awesome, that guy also has to be 30 degrees, because that's how isosceles triangles work. And every single triangle have the angles add up to 180. So 30 plus 30 plus what you're missing has to equal 180. Or 60 plus x equals 180. Subtract 60 from both sides, and you have x equals 120. It's as easy as that. Question 5. Angle EFG is the same measure as angle GEF. So EFG is the same measure as GEF. What fun. Another isosceles triangle. If EG is 7 inches long and EF is 3 inches long, what is the perimeter of the triangle? Oh, this is an easy one. Come on, this is a waste of our time. If this is an isosceles triangle, and you know that because these two angles are the same, that this guy has to be the same as that guy, and we can add 3 numbers together. That's not hard. 7 plus 7 is 14 plus 3 is 17. We're good. Question 6. What is the height, H, of the equilateral triangle below if AB is 10 inches? Okay, this is a famous, what is the height of an equilateral triangle? And if you know the height, you could get the area too, right? Because it's just height times base divided by 2 for a triangle. But we only need to find the height here. We have a right angle and we have an equilateral triangle. So let's do this. We know this is 10, we know this is 10, and if this is 10, the whole thing, then this is 5 and this is 5. Okay, what is the height? Well, we know if we have a triangle that's a right triangle, that a squared plus b squared will equal c squared. Haha, it says equilateral triangle and you're like, oh, I'm thinking equilateral triangles, but really it's a Pythagorean theorem, right triangle question. So let's do it. What's a squared? Well, that's our unknown. A squared is our unknown, right? What is b squared? That's 25. And c squared is 100, so we're going to minus 25 from both sides, and we get a squared equals 75. We're going to get the square root of each side. Square root of a squared is just a. Square root of 75, let's call that 25 times 3. Square root of 25 is 5. Square root of 3 is 3, so your a, or your height, is going to be 5 square root of 3. Do I have that as an answer? I certainly do. There we are. Question 7. AB equals 2x minus 3. BC equals x plus 7. And CA equals x plus 16. Angle BCA equals angle CAB. So BCA equals CAB. What is the perimeter of the triangle? And you're like, oh my gosh, how could I possibly do this? I have variables, and normally when I have variables, they equal something, but here you have variables and they equal P perimeter. So you have 2 variables, you don't know what to do, and you're like, oh my gosh. But you do remember that we're dealing with an isosceles triangle here. You know that because 2 angles are the same. And if these 2 angles are the same, that means these 2 sides, 2x minus 3, must be the same. These 2 sides must equal each other, right? This side and this side must equal each other. So 2x minus 3 must equal x plus 7. If you minus an x from both sides and add a 3 to both sides, you will get, 2x minus x is x. This cancels out, and 7 plus 3 equals 10. You will get x equals 10. If you have x equals 10, well, that's 20 minus 3 is 17. Unsurprisingly, the side that has to equal this is also 17, because x plus 7 is 10 plus 7 is 17, and x plus 16 is 26. And you see our distractors here, like leave a variable in there. How clever I was to put those in there. They might distract you because they're like, oh, you can't do this, but you can do this. 17 plus 17 is 34. 34 plus 26 is, well, carry the 1, 60. We're good to go. Okay, question 8 is like my favorite question that I ever made up ever. I mean, I took bits and parts from other questions that I've run into throughout my day, but I made this up. The final version is mine, and I'm so excited about it. I showed it to the other math teachers here. They were excited too, because, we're nerds. Nerds rule the world. If you're not a nerd yet, you totally should be a nerd. This is good. This is fun. In triangle below, angle BAC is 20 degrees. Okay, so this guy's 20. And side EB equals BD equals BC equals CD. Oh, wait a second. This guy equals this guy equals this guy? That means that's an equilateral triangle. BDC is an equilateral triangle. Okay, what's my question? What is the measure of angle BED? BED. So that's the angle we're looking for. And we're like, how do we do that? Okay, well, if we have an equilateral triangle, we know that this guy is 60, this guy is 60, and this guy is 60. If we have an entire triangle, it has to add up to 180. So if we have, I'll just draw it again, B, A, C. We know BAC has to add up to 180, and we know A is 20, and we know C is 60. So we know 180 must equal 20 plus 60 plus something, right? And that 20 plus 60 is 80. So this B, that must equal 100 degrees. Because 100 plus 80 equals 180. This triangle must add up to 180. So this whole angle here, not the 60 part, but the whole part must be 100. And if this whole part must be 100, and this is 60, we know that this part must be 40. Think about it. This whole thing has to be 100 because 100 plus 20 plus 60 gets you 180. And this whole thing being 100 and this part being 60 means that part is 40. Okay. Now we have B, E, D. And we know that this guy is 40. But what do we do? Well, we know this side is equal to that side, right? That side is equal to that side. So we have the magical, the wonderful isosceles triangle. It's a great friend of ours. It came back to visit. What fun. Okay, so BED equals 180, right? Because all the angles of a triangle have to add up to 180, and E and D must be the same measure. Because it's an isosceles triangle, and that's how isosceles triangles work. If this length is the same as that length, that angle has to be the same as that angle. So we'll just call that angle length x. And we have 2x plus 40 equals 180, right? Because all the angles have to add up to 180, and these guys got to be the same. So if x plus 40 equals 180, 2x plus 40 equals 180. Subtract 40 from both sides. We have 2x equals 140. Divide by 2. X equals 70. All right, we're good. Question 9 is awesome. I really like question 9. In the figure below, A, B, C, D is a square. Okay, that's cool. And ADE is an equilateral triangle. Yay. What is the measure of EBC? That is our question. Okay. Well, how do we do this one? Well, how are we going to start? Well, we know this guy's got to be 60. This guy's got to be 60. And this guy's got to be 60. Why? Because that's the way equilateral triangles work. And if this is a square, has to be 90, right? Because that's how squares work. All the angles are 90 in a square. So if this has to be 90, here has to be 90, and this part of it is 60, well, what does that leave this part? That part has to be 30. Okay? So work with me here. 30 degrees. This is 30 degrees. What else do we know about this? Well, think about it. If this is an equilateral triangle and this is a square, what do we have here? Well, we know this side is the same length as the side of the square, right? This is the same length as the side of the square. So that means these two have to be the same length. Think about it. That has to be the same length as that. And if that's the same length as that, we have ourselves, wait for it, an isosceles triangle. What fun. Okay, so we know a triangle that is isosceles has the same angle measurements in two of its corners, and all triangles have to add up to 180. So if we just treat this as x, we have 180 equals 30 plus angle here, angle there, 2x. So subtract 30 from both sides. We have 150 equals 2x. Divide by 2. We have x equals 75. And we know it. Now we know that this angle here is 75 degrees. Well, if we have a square, which we do, ABC has to be 90 degrees. If this part of the 90-degree angle is 75 degrees, what does EBC have to be? Well, it has to be 15, right? Because 75 plus 15 equal 90. We're good to go. Question 10. Oh my gosh, question 10. Another awesome triangle question. In the cube below, what is the length of C in terms of A? And C you can think of as the diagonal between one corner and the other far, far away corner of the cube. And you see a cube and you're like, oh, this is, a geometry problem. And it is a geometry problem because you're dealing with triangles, but it's not a cube problem, it's a triangle problem. But what do we know about cubes? We know all sides are the same. So we have A, and A. We also have B and C. And if you think about it, I know this is a little kind of mind warping if you don't have a cube in front of you. But look at this. ABC itself is going to be a right triangle. So we have a right triangle here with AAB, and we have another right triangle with BAC. Just think about it for a second. If you have a cube, that is going to be a right triangle. I know it's tough. Don't fight it. Just let it happen. Okay, so if we have A, B, we know the length of B in terms of A is going to be A squared plus A squared equals B squared. A squared plus A squared equals 2A squared, and that equals B squared. Now I'm not going to get the square root of both sides, although I could. It would be fun, but I'm not going to do that right now because I know that if B, just watch what I do here, B squared here, if you have BAC, you need, this is C. You're going to have, again, A squared plus B squared equals C squared. Now watch this. This B squared is like that B squared. So if I know A squared's here, and I know this B squared's there, but B squared I know equals 2A squared, I can just swap it out there. Save myself like a couple seconds. That's cool. A squared plus 2A squared equals C squared. That's 3A squared equals C squared. Get the square root of both sides. What's the square root of C squared? You know that, that's C. Square root over here is like 3 times A times A. A times A is A squared. Square root of A squared is just A. Square root of 3 is just the square root of 3. And that's it. That's our answer. A square root of 3. That's a tough one, but we're good.